Thank you so much for having me today. So I'm going to be talking about some of the outreach that we did aboard the RV Roger Revelle this past summer, which we called Ship to Shore. So here we go. All right. So this past summer, my lab group and some of our colleagues, we went to sea, in Labrador Sea, and we wanted to do some outreach work. So I'm going to be talking today, just giving a little overview of what we called the SEALs cruise, and I'll explain why we called it that in a minute. And then I'll also talk about how we went about planning these ship-to-shore sessions, especially if anyone who goes out to sea regularly is interested in sort of recreating this model, talk a bit about kind of what we did and how it might apply elsewhere. And then also some of these impacts and the importance of doing this type of outreach work as well. Right, so this past summer we went, to sea. Before I talk about the outreach, I want to give a little bit of context for the cruise and why we were there in the first place. So I know this is a seafloor specific seminar. I'm more of a seawater chemistry research. I study rare earth elements, specifically neodymium isotopes in seawater. So I just want to give a little bit of context about kind of what we were doing and how that kind of what instruments we had on the ship, as a result of that. And so if we look at the distribution of deep water, so, deeper than 1,500 meters, neodymium isotope values, we can see that the North Atlantic has more negative values than in the North Pacific. That's because the surrounding rocks that contribute that neodymium into the seawater, there's a preferential incorporation of samarium-147, which decays into that radiogenic neodymium-143 in younger, more basaltic rocks like we have near ridges and in the North Pacific, and a preferential incorporation of neodymium-144 in older continental rocks like those around the North Atlantic. And the important thing to take away from this is that this results in these deep water, at these different ocean basins with these distinct neodymium isotope values. And we can use this now as a water mass tracer in the global ocean for reconstructing past changes. I know some of the people in my lab actually work on IODP cores and look at marine archives and reconstructing, changes in circulation with that. But this proxy is built on this framework that these bottom water values reflect the mixing of these end members at locations away from the site of that end member formation. Now, if anyone else works with proxies, they always sound great, but then there's other complications to take into consideration. And additional studies have suggested that the contribution from sediments could actually influence that deep water neodymium signal and impact that use of the tracer. So the value that we're getting is not just mixing, it might also be influenced by that sediment contribution. And that was the major focus of this research cruise from last summer. So we collected sediment and seawater samples across the Labrador Sea, starting in sort of the Labrador shelf, transect across the basin towards the Greenland side. And we were collecting, looking at the sediments and seawater, so we called it sediment exchange along Labrador Sea. So that's how we got the SEALs name. And we had that goal of quantifying that sediment flux and how it influenced that bottom water signal. So on this cruise, we're collecting a lot of sediments. So we're using our multi-corer, and that would give us that top 20 to 30 centimeters of ocean sediment in these cores. And we would slice those cores, and extract that pore water, because we wanted to analyze it. And we would also do CTD casts to collect seawater. And of course, those of you who've been to sea may have done this yourself. We attached, styrofoam cups that we decorated and sent them down with the instruments so that they would shrink under pressure. So the main reason I'm sharing all of this is because these were the instruments we had on our ship because of those scientific questions and the samples that we were trying to get. Now, you might go on a research cruise where you have very different sampling methods and very different instruments available. Maybe you go and you're dredging rocks from the bottom of the ocean. So the goal when we talk about outreach and communication is what aspects of our research and sample collection is exciting and dynamic and can be easily shared with the public. Right, so we would explain in these sessions that we collect mud and sediments from the bottom of the ocean, but how do we go about getting it, right? We can't just dive down and scoop it up because the pressure is too great. And that's one of those things that those styrofoam cups did such a great job demonstrating is that pressure difference. So we can share some of these tools that we use and explain how they work. And, especially if you've been doing this a while, it might seem kind of obvious to us, but it's important to think, especially when we're talking to kids, what might be exciting and novel for them. Right, so in planning and setting up these sessions, there's a lot of work that actually has to be done before we leave port. So the first step is to find schools or organizations to participate. And this can be challenging depending on the time of year. In the US here, over the course of the summer, schools are not in session. And so we had a cruise during June, July. So the second half of the cruise, most schools weren't in sessions. So we also reached out to summer camps and teacher professional development over the summertime. But if you are at an institution that has an education program, they might have a connection with either local schools or teacher associations. You could reach out to them, and then also personal connections. We had a lot of participants because either people had kids or had friends with kids, and we would reach out to their teachers and set up sessions that way. So once you've sort of established participants, you want to have one person who's sort of the point person, which is kind of what I was, to kind of communicate with them and also all of the scientists on board. But it's too much to do really just by yourself. So it's good to also establish sort of a core team from the science party who will be involved in these sessions. So we would have one person kind of as the main person, talking with the schools. One person we used an iPad, but sort of the camera, and then somebody else who could maybe run ahead and just make sure, oh, are they deploying the multi-core or can we go out on deck and talk about it? So then we would schedule the sessions. We used Zoom to communicate with the schools, and we were running a 24-hour ship, so we could accommodate whatever time worked best for the schools. But you want to schedule ahead of time and make sure that the crew and everyone on the science party kind of knows when these sessions are happening. And then lastly, planning out, okay, what are we going to do during these sessions? So we actually had a website for the cruise that we could share with teachers ahead of time, and they could give some context to their students and also send us questions ahead of time that their students might have. And that was really great because it allowed us to sort of create the session around the interests of the students. If they had any specific questions, we wanted to make sure we covered that. And also, very importantly, it would help the teachers connect what the students were learning about in school to anything we might be doing on the ship. So kind of help tie that in. All right, so now we've got our sessions scheduled. We want to start planning them. What are we going to do? We've got sort of this hour-long session that we're going to be talking with students. And so before I started working in my graduate program, I used to work at the Academy of Natural Sciences, which is a natural history museum in Philadelphia. I did a lot of the public outreach type work at the museum. And one of the biggest takeaways when you're dealing with the public, especially with kids, is that one, you need to stay flexible, and two, the most important thing is you want to help people feel excited and engaged, right? So we had typically 1 hour long sessions, and we're going to talk a lot about science. Students might not remember every single thing, every fact that we share. So the goal is we want them to leave with an enthusiasm and a passion for science and research, and also have this feeling of involvement in some of the work that we do. So we would keep the same general structure. We'd start with about a 5-minute introduction of, especially whoever sort of are the people in front of the camera, something like, hi, I'm Cory Hite. I'm a PhD student here aboard Roger Revelle, and I am talking to you from in, the middle of the Labrador Sea, something to give some context to, the session and sort of what you're going to be talking about. And we also knew we wanted to have time for questions at the end. So that would leave about 25 to 35 minutes for the actual content, right? And so we wanted to show them some of the instruments like the multi-core and the CTD, demonstrate, and talk about how we would collect seawater or sediment from, 2,000 meters below sea level. We also, students were really interested in seeing different parts of the ship and what living on the ship was like. So we talked to the crew and made sure it was okay that we could show like the lounge and the galley and the mess, because that was something else that was really exciting for students to see. And we also made sure that everyone who participated, other scientists, we even had some crew join and talk to some of the students, which was really great. We wanted them to share their career journeys and show, there's a lot of different ways of getting involved in this work. And we had undergrads through a professor who this was, over 50 cruises he's been on. And so being able to sort of talk about that background and kind of why they got interested in this kind of work was also really exciting and valuable. And then lastly, we wanted to end with, make sure we had time for students to ask questions. So we would save at least 10 to 15 minutes for question and answer. But I had mentioned before, it's important to stay flexible. And sometimes we would be showing the multi-core and the students would get so excited about that, we would run out of time to show them the CTD, right? And so again, the goal is we want to have them excited about this work. We want to pique their curiosity. And so if we don't show them everything we had originally planned, that's okay. The goal is just to make sure that they were engaged and excited about being involved in some of this work. All right, so we were out for about 5 weeks, and we had 10 total sessions during that time. One was with a summer camp at Oklahoma State University. Most of the sessions were with school classrooms. We had both in the United States and in Switzerland. And then we also had two sessions that were specifically for teachers, kindergarten through 12th grade teachers, as part of a professional development for teaching science. Now, it's difficult to say exactly how many students we spoke to because some of our participants would be just a couple of students, and then some would be, auditoriums with hundreds. But we estimated we spoke to about 1,000 students over those 5 weeks. And then once we were back on land, we would send the participating classrooms some of those styrofoam cups so that they, even after, the session was done, those teachers had that resource and they could say, hey, this was at the bottom of the ocean. Let's talk about how that pressure changed, and have something they can use in the classroom to get their students excited. Right, so I've spent some time explaining, what we did, how we did it, but this is really why we care about doing this type of outreach work and communication work. So we're only talking to these students for about an hour-long Zoom call, and the goal is to have them see how exciting science can be. There's different paths to getting involved in this research. Like I said, some of the crew got involved and talked about, going in that route if you want to be involved. Kids asked a variety of different questions, excited about sampling and how we collected samples. Some connected it back to what they were learning about in school and asked, how is the work we're doing related to things like climate change? Many of them were interested in just living on the ship. We were asked, where do you sleep? How do you go to the bathroom? That was a very common question. And then a lot of them were curious about just the experience of being at sea and what kinds of things we've seen from the ship. Have we seen any whales? Have we seen any cool marine life? And we just wanted to expose the students to, the equipment, life at sea, all these different career journeys. And kind of at the end of the day, we hope that some of the students are going to want to go on to become oceanographers and scientists, but not all of them are going to be, and that's okay. But we hope that they were instilled with sort of this interest and value of the work that we do in scientific research. So even if they don't end up becoming scientists, if they go on into business or law or whatever, they have an appreciation for the work that we do and kind of a love for science research. So we had a big team of people from the science party who were involved from the planning stage through, you know, just being in front of the camera and communicating with the students. Everybody on the science team was very supportive, even if they weren't necessarily comfortable being behind the camera. And then I also want to thank the entirety of the crew for being so supportive and also being willing to talk to some of the students and share their stories. So thank you so much again, and I am happy to take any questions.